Okay, objective 3, we are looking at basic trig proofs. And then you will be doing trig proofs, just for the record, in almost every single objective from here until the rest of the unit. There's a couple maybe that don't have it, but they're going to be there over and over and over again, because this is something that we have to continue to practice. Unlike solving, where there is a right answer, and while there's some wiggle room maybe with how to get to that right answer, there's a lot of times kind of one way of getting there, right? Or I'd say there's usually one more efficient way of getting there. That's not true for proofs, and you'll see that as we get into our practice today, and is why we have to continue practicing, because chances are, while there will be some of us who at the end of this first practice here, objective 3 with proofs, are going to be sitting there going, oh, I don't feel too bad about proofs. There are going to be others that are going, I need some more practice. And again, that's why they will be there over and over and over and over again. This is not something that will just be objective 3. Okay? Before we get into these proofs, we have listed at the top here some important identities that you'll be using. Some of these we had in our objective 2 notes already, and then there's a couple of ones that we have not seen in our notes, but are ones that we need to know. So we have the reciprocal ideas that we looked at already in objective 2. We have those quotients. The 3 Pythagorean identities are once more here in our notes, that we have them to reference. We've got our opposite angles, which we looked at why these opposite angles work in objective 2. And then we have our 3 complementary cofunctions, which are that sine of pi over 2 minus cosine sine of pi over 2 minus theta equals cosine, tangent of pi over 2 minus theta equals cotangent, and secant of pi over 2 minus theta equals cosecant, which are our 3 additional identities that we now have in our toolbox. Which brings us to our proofs. Okay, so before we get into proofs, let's go ahead and talk about some rules and strategies for trig proofs. First rule, and it is bolded and italicized to make sure that we keep this in mind. A finished proof may only work with one side of the equation using logical, step-by-step trig identities. What I mean by that, and what we mean by that, is this. If you take a look at number 1 here, we've got sine squared x over tangent squared x equals cosine squared x. Our goal, and I referenced this in the objective 2 video, but our goal is to try to get one side of this equals to match the other. And what you're going to see as we get into these is, technically speaking, you can work with either side. I can work on the left or the right. But what I cannot do is take anything that is on the left, so either this sine squared or this tangent squared, and somehow move it to the right. So it's going to be tempting sometimes to say, like, oh, what if I multiply tangent squared x over? Nope, you can't do that. Or maybe we have something added over here and we go, oh, what if I subtracted it to the other side? Nope, you can't do that. That is not a proof. A proof is taking one statement and manipulating that one statement to look like the other. We do not mix the 2 statements. And so anything that started on the left will stay on the left. Anything that started on the right will stay on the right. You will pick one side of the equation to work with. And by going step by step, you will manipulate it to look like the other. And that is an important thing to keep in mind with proofs. Okay, in terms of strategies, my first recommended strategy is that it's generally easier to start with the messy side of the equation, right? You're going to look at the 2 sides of the equals and you're going to go, okay, which one looks scarier? Which one looks messier, more complex? That's the one, generally speaking, we're going to manipulate. Because like objective 2, we're a lot of times going to take that messy side and condense it using all of those strategies we looked at in objective 2, factoring, distributing, rewriting with our trig identities that we have listed up here, those kind of things. It's usually easier to go from messy to more simple than to go from simple to messy. Going from simple to messy means you're having to interject additional trig things, and usually those are kind of hard to see what you would interject. And so we generally will work with the messier side and try to clean it up to arrive at the other side of the equation. Now, that being said, a strategy, and you'll hear me reference this even as we are continuing through our trig practice, a strategy is that if you are working with one side and you get stuck on a different piece of paper or off to the side on your piece of paper, try manipulating this other side, but again, you would do it elsewhere because finished trig proof, we can only work with one side, so you would do it somewhere else. But you'd try manipulating that other side and see if you could get the other side to match to where you got stuck. Because if you can get it to match where you got stuck, then you can reverse those steps that you took to finish out the side you were working on, right? And so it can help you, like you kind of meet in the middle almost, and then use that to help you finish out your original proof. But again, one more time, a finished proof, you will only have worked with one side of the equation, and you'll get it to match the other. Okay? So generally we work with the messy side, but again, it's not a bad thing. If you want to play with the other side off to the side of a paper on a separate piece of paper just to see if you can kind of meet in the middle, it's not a bad idea. Okay? Number 2, factoring sometimes is helpful. Again, looking for GCFs or trinomial factors. Number 3, we can simplify by combining fractions, right? If you see a common denominator you can find, a lot of these are going to sound kind of like objective 2. Number 4, if the denominator of a fraction consists of only one function, break up that fraction. We referenced this in objective 2, is the idea of splitting your fractions. So if you have I don't know, we'll say cosine minus 1 divided by sine, or cosine x minus 1, I should say, divided by sine x. This is what this step 4 is saying, is if the denominator of a fraction consists of only one function, like sine x, you could break up the fraction. We could rewrite this as cosine x over sine x minus 1 over sine x, right? Because think about that. We're allowed to do that because since these have a common denominator of that sine x, I could combine them, right? Cosine minus 1 all over sine, cosine minus 1 all over sine. So if you were working here and you had only one function in the bottom and you were wanting for some reason 2 different terms, for some reason, you could split it. This would allow you to say, okay, cosine over sine is cotangent, 1 over sine is cosecant, and maybe that's what I was wanting to get to. I don't know. Again, I just made up these trigs randomly, but that's that strategy, number 4 there. Okay. Number 5, if there are squares of functions, look for alternate forms of the Pythagorean identities, right? These 3 up here. A lot of times squareds will somehow fall in this realm. Number 6, change everything to sines and cosines. I made that recommendation in objective 2, right? So it's still here as a recommendation. Sometimes one must multiply by the conjugate of either the numerator or the denominator. So quick review, you can add this off to the side here if you forgot what conjugates are. But conjugates are like if you had 1 minus secant x, you might multiply by 1 plus secant x. Because in doing so, we would have 1 times 1 is 1, 1 times secant is secant, negative secant times 1 is negative secant times positive secant is negative secant squared. Right? Secants would simplify and we'd have 1 minus secant squared x, which looks a lot like our Pythagorean identity up here, a manipulated form of that Pythagorean identity, and we could potentially proceed from that point. But so this is 1. Number 7 is saying if you look at your numerator or denominator and you see kind of a 1 minus sine or maybe it's a 1 minus cosine or I don't know, something like that, you could multiply by 1 plus sine or 1 plus cosine. Or vice versa. Maybe you're looking at 1 plus cosine, you might multiply by 1 minus cosine. So that's what that 7 is consider multiplying by the conjugate. 8, if you have negative angles, consider your opposite angles. Again, those are listed one more time up here like they were in objective 2. Complementary cofunctions is number 9 recommendation. These are your complementary cofunctions for number 9 there. And then 10, this is my recommendation. Avoid introducing radicals. I sometimes have students who want to square root things. Try to avoid square rooting. Very rarely does that actually end up helping. It's not a bad thing to keep in the back of your mind. Maybe there's a scenario where you would want to, but generally speaking, if you find yourself introducing radicals, you're generally making your function more complicated. And our overarching goal, remember, is to take the messy side and generally try to clean it up. Introducing a radical, probably not going to be cleaning it up much. So again, if you find yourself with a square, try to avoid the square root idea. Generally, squareds cue a Pythagorean, or potentially there might be some sort of reciprocal or quotient that you could rewrite. So avoid radicals, okay? Excuse me. Okay, so those are my recommendations for proofs. Here we go. We're going to walk through a couple of these together, and then my recommendation for you is to start kind of pausing and trying them on your own, or maybe getting a step ahead. Remember that there isn't one way through these problems. There just isn't. I'm sorry. I wish I could tell you that, like, oh, doing it this way will always work. There's not one way to work. You have to be willing to try something. You can't just look at the problem. Do something. And again, if you've been working with one side of the equation, you get stuck, then take the other side, move to a different piece of paper, try manipulating that sum, and see if you can get the other side to match where you got stuck. And then you can reverse your work to help you finish out the proof, right? And so that is one strategy to help you get unstuck. But at some point you have to try something. If it seems to not be working, you have to be okay going back to the beginning and trying something else, or maybe backing up a couple of steps and trying something else, because you just, there isn't going to be one way through the problem. There just isn't. Okay? Okay, so taking a look here at number 1. First step, we got to decide which side of the equation we want to work with. Again, technically you can work with either side. My recommendation, pick the messier side. Which sometimes even that there's going to be a disagreement. Some people might view the left as more messy versus other people who view the right as more messy. So you kind of just got to pick one in those cases. But in number 1 here, in my personal opinion, I think the left's more messy, right? There's more stuff over there as opposed to the right side, which looks nice and clean. It's like one term. I personally would recommend working with the left. Okay, so that's what we're going to do on this video. So I want to get this sine squared divided by tangent squared to equal cosine squared. So what could I do here to manipulate the left? Okay, well, dividing by tangent, I know what dividing by tangent is. Dividing by tangent is the same thing as cotangent. And so maybe I go, okay, well, dividing by tangent is the same thing as cotangent. And like we did in Objective 2, we write it. Not because we know it's going to work, but because we're trying something, right? We're not just looking at the problem. And then we sit there and we go, okay, well, I'm still not at cosine squared. I want to get this to be cosine squared. What now could I do? Okay, well, cotangent, I know how to rewrite cotangent. Cotangent is the same thing as cosine divided by sine. And so maybe I rewrite cotangent as cosine divided by sine, and I see, does that help me unlock anything to get me to match cosine squared on the right? Well, yeah, I got side squares that can cancel. Woohoo! If I cancel those cosine squareds, I'd be left with, or those sine squareds, I'd be left with cosine squared on the left, which equals cosine squared on the right. And what do you know? I've now got my two sides to match. My proof is done. I mentioned in Objective 2 that the nice thing here about Objective 3, ladies and gentlemen, is while there isn't one right route through the problem, you know your answer from the beginning. My answer, the minute I decided to work with the left, my answer was going to be cosine squared equals cosine squared. You know your final destination. You have to be willing to play in between and potentially try some stuff that doesn't work and maybe erase it and try something else. But you know what your answer is. There is no question what your answer is. It is going to be cosine squared equals cosine squared. I'm going to get my left to match my right. Okay? Okay, number 2. We got to pick a side to work with. I don't know about you. I look at this one and I go, well, these both kind of look messy. And so you just kind of got to pick one. It doesn't really matter which one you pick with. We picked the left last time, so let's pick the right on this one. Let's manipulate this side to try to get it to look like this one. Okay? So I'm not touching the left. The left will say cosine beta the whole time. Cosine squared beta minus sine squared beta, I should say, the whole time. That's not changing. Okay, so we're going to look at that right, and we're going to go, okay, well, what could I do? Okay, well, I see that sine squared. I don't really know what to do with the 1 and the minus 2, but sine squared, I know something I could put into sine squared. What could we put into sine squared? Okay, well, our Pythagorean identities tell us that sine squared equals 1 minus cosine squared. And so let me go ahead and put in 1 minus cosine squared. Okay. So then we're sitting there and we're looking at it and we're going, well, I don't know about that one. That doesn't seem to really unlock anything for me. Maybe I distribute the 2 in. Okay. I'm going to spoil it slightly here, only just because I don't really know how to model it on a video any other way. So this is my attempt to try to say, like, sometimes, ladies and gentlemen, you might reach a point and you go, ooh, I don't know. I got a little bit stuck. Well, if that happens, it's okay. Cross it off, erase it, something. Try again. Maybe you had a different idea of what you might try on the right. And maybe at this point you go, ooh, well, maybe I don't want to manipulate the right. Maybe I want to leave the right alone. Maybe I want to try manipulating the left instead. And it's okay to change your mind. Right? That is part of the proof process. And again, that's really hard to model on a video. So this was my attempt to try to model going, well, okay, I'm going to try something else now. That's going to happen. Maybe it happens on another one of these example problems for you. Maybe it happens on the homework. Maybe it happens in a different objective altogether. Because again, we're going to keep practicing proofs in every objective. But you have to be willing to restart or to back up a couple of steps and try something else. Right? And so maybe you're sitting there going, oh, I don't know. Maybe I don't want to manipulate the right. Maybe I actually want to leave my right alone. Leave that as 1 minus 2 sine squared beta. And maybe I want to try manipulating my left instead. Right? And so then we look at that cosine squared minus sine squared and we go, well, compared to my right, there's no cosine squared on my right. What if I got rid of that cosine squared that currently is sitting on my left here? What could I substitute into cosine squared? Okay, well, Pythagorean identity says that cosine squared equals 1 minus sine squared. What if I plug in 1 minus sine squared beta into that cosine squared? And I'll leave this minus sine squared there. Does that allow me to do anything? Well, what do you know? Now we've got common terms here, like terms. Sine squared beta minus sine squared beta would be 2 sine squared beta. And what do you know? I've gotten my left to look like my right. And our proof is done. And I'm sorry, you might have been able to manipulate the right and get it to look like the left. There is a way to do that. I even have it in one of my worked out answer keys. So that, like, it's not that you have to work on the left. You can work on the right. I just was trying to model a situation where you might get stuck or go, I don't know. And you got to be willing to maybe restart or try something else, back up a couple steps and try something else. Okay? There will always be a way, though, to get them to match. And again, in the final proof, you can only work with one side. You cannot manipulate both. Right? Okay. Turning the page here, let's go ahead and take a look at example 3. We have secant to the 6th alpha times secant alpha tangent alpha minus secant to the 4th alpha times secant alpha tangent alpha equals secant to the 5th alpha times tangent cubed alpha. Whew! Okay, so we got to pick. Which side do we want to work with, left or right? And my recommendation, pick the one that looks more complicated. Okay, well, I don't know about you, but in my opinion, the left is more complicated than the right. So I'm going to work with the left. And then this time I won't switch on you, right? Again, I was just trying to model in number 2 what it's like to get stuck to the best of my ability. Okay, so I'm going to work with the left. So if you want to do the same, go ahead and take a look at the left. And what can we do on the left to try to get it to look a little bit more like the right? Okay, well, I look at that left and I go, well, the first thing is I could actually multiply these, right? I know what secant to the 6th alpha times secant alpha is. It's secant to the 7th alpha. And then if nothing else, I'm getting rid of the parentheses. Secant to the 4th alpha times secant alpha is secant to the 5th alpha. Again, I'm not going to touch the right. My right will stay secant to the 5th alpha tangent cubed alpha the whole time if I'm working with the left. Okay, so then I'm going to look at the left and go, okay, well, I'm still not matching, so what else could I do on the left to try to get it to look more like the right? Okay, well, I see I've got a common term here, right, a GCF. There's a secant to the 5th alpha tangent alpha that is in both of these two terms. And so maybe I factor that out. Again, one more time, not because I know it's going to work, but because it might unlock something. Well, if I factor that out of the first term, what am I left with? I'm left with secant squared. And out of the second term, I'm left with 1. Okay, so now it's looking closer to the right. I see this secant to the 5th alpha and secant to the 5th alpha. That's looking closer. This one, though, has this stuff on the left. The right is just tangent cubed. So then I'm going, okay, well, what else could I do to try to get my left to match my right? Okay, well, that secant squared alpha minus 1 is a Pythagorean identity. Secant squared alpha minus 1 would be tangent squared. And so maybe I plug in tangent squared. And I go, does that help me do anything to get my left to match my right? I'll take a step back and look at it. And yes, it does, right? I know what tangent alpha times tangent squared alpha is. Tangent alpha times tangent squared alpha is tangent cubed alpha. And I've now gotten my left to match my right perfectly, and my proof is done. Okay, so I'm hoping you're starting to kind of see what this looks like, how this plays out. My recommendation would be now to either, like I said earlier, either pause the video and try one of these on your own, or maybe to get a step ahead if you're kind of wanting to see which side I'm planning to work with as I walk through the video, maybe listen to which side I'm planning to work with, and that way your work maybe looks a little bit more like mine. But again, at some point you need to start practicing these on your own. You can't just copy down what I'm doing. That's not doing you any good. You have to be willing to try stuff, to make mistakes, to restart. Okay? Okay, so pause the video if you're going to do so, or if nothing else, like I said, try to get a step ahead. Number 4. Okay, we're looking here. We got to decide which side am I going to work with. Okay, well, I'm going to work with the left, because to me the left looks a lot more complicated than the right does. Okay, so then we're going to look at that left and go, okay, well, what could I do? Okay, well, I'm sitting here going, I don't really know much what to do with that numerator right now, but the denominator I could do something with, right? I know what divided by tangent means, and I know what divided by cotangent means. I can rewrite divided by cotangent and tangent. What does divided by tangent, how does that get rewritten? Okay, well, divided by tangent is cotangent. And so I could rewrite this divided by tangent x as cotangent x. What about the dividing by cotangent? Okay, well, dividing by cotangent is the same thing as tangent. And then I'll go ahead and just write my numerator, because, again, I don't really know yet what to do with my numerator, but I'll just leave it there. Right side of the equation is going to stay exactly the way it started. I will not touch that right side at all. Okay? So now I'm here and I'm looking at the left going, okay, well, what else could I do to get it to look like the right? Okay, well, the left has parentheses, the right doesn't. So maybe I try distributing. Cotangent x times tangent x times the tangent y. And and cotangent x times the tangent y times the cotangent y. Right side stays the same. Okay, so then we're sitting here and we're going, okay, well, left to right, I still have a lot of terms on the left. Somehow some of these must end up going away. How could I get some of these ones on the left to go away? Okay, well, some of us, we're going to look at tangent x times cotangent x, and we're going to know how to simplify that. And if you look at those and you already know that those cancel and make 1, you're more than welcome to do that. For others, we're going to look at cotangent x and tangent x, and we're going to go, I don't see how that makes 1. And so maybe you substitute in your cosines and sines, right? Cotangent x is the same thing as cosine divided by sine. Tangent is the same thing as sine divided by cosine. And when you do that, you'll notice the sines will cancel and the cosines will cancel. Same thing will be true over here, right? If we plug in tangent y and make it sine divided by cosine, and cotangent, make that cosine, whoops, that should have been y there, sorry. Cotangent would be cosine divided by sine. What we notice is that our sines and cosines cancel. And what that leaves on the left side of my equation is simply tangent y plus cotangent x, which matches my right perfectly. And my proof is done. Okay? Okay, number 5 is up next. Number 5, we have cosine divided by 1 minus sine equals secant plus tangent. And so we've got to start with which side do we want to work with? Which side do we think looks more complicated? Okay? Well, in my opinion, the left is more complicated. So I'm going to work with the left. I'm going to leave the right alone. Again, you might disagree, and that's fine. There's a way to work with either side and get them to match the other, but I'm going to work with the left on this video. Okay? So, what could we do with that cosine over 1 minus sine? Okay? Well, I don't see a whole lot else, but what I do see here is something that looks a lot like that conjugate idea we talked about as we were going through our recommended steps. Conjugates, here's our little conjugate post-it. As a reminder, conjugates are when we have like a 1 minus something and we multiply by a 1 plus something. Or we have a 1 plus something and we multiply by a 1 minus something. We can FOIL it out, right? And so I'm sitting here looking at that denominator going, well, I see a 1 minus something. What if I multiply this first term, top and bottom, by 1 plus sine something? By the way, I'm going to change my variable here to be x. So I'm going to multiply top and bottom by 1 plus sine x to that original cosine over 1 minus sine. This is called multiplying by the conjugate. And when we do that, my numerator now is the cosine times that 1 plus sine. My denominator, FOILing this out, 1 times 1 would be 1. 1 times negative sine would be negative sine. Sine times 1 would be positive sine. And sine times negative sine would be negative sine squared. Again, the right is staying the same the whole time. We're not going to manipulate the right at all. Okay, well that allows those sines to cancel. And I'm left with 1 minus sine squared in the denominator. What does that allow me to do? Okay, well, that's a Pythagorean identity. 1 minus that sine squared is cosine squared. Right? So my numerator is cosine over 1 plus, or times 1 plus sine, all over cosine squared. What can I do now to the left? Well, I've got cosines that can simplify now. So my numerator would just be 1 plus sine over a singular cosine. I'm sitting here looking at this one. Okay, I'm wanting to, again, to model a problem-solving strategy when it comes to proofs. Some of us might look at this and already know what we can do. But maybe this is a situation where you can implement what I talked about earlier, which is if you do get to a point where you're like, man, I'm stuck, I don't know how to get it to match this side. Well, on a different paper or off to the side, take the other side and try manipulating the other side to get it to match where you got stuck. Right? This is a strategy for when you do get stuck in your proof process. Now again, we can't actually manipulate the right side on our proof, but it's okay if off to the side you try doing some manipulation to see, can I get it to be 1 plus sine x over cosine x? Okay, so what if we tried that just to see if that unlocked anything? What could we do to this secant x and this tangent x? Okay, well, we could use our Pythagorean identities, right? Secant x is 1 over cosine x. Tangent x is sine x over cosine x. And what do you know? We've now got a common denominator, which means I could combine them. And that matches what I have here. This strategy, ladies and gentlemen, allows us to say, okay, now that we've gotten our right to match our left, what if we undid these steps? 1 plus sine x over cosine x, we could rewrite that as 1 over cosine x plus sine x over cosine x. That's called splitting the fraction. That was another strategy we talked about at the beginning of the video. And now that we are here, we can rewrite the 1 over cosine x plus sine x over cosine x as secant x plus tangent x. And now we've gotten our left to match our right, and our proof is done. Again, you don't have to do this strategy. It's just something to keep in mind if you do end up getting stuck. Don't hesitate to pull like a scratch piece of paper off to the side or something like that and try working with the other side. Try to get the two of them to match and then work backwards to finish out the proof you had started. Something to keep in mind. Okay? Okay, we've got two more here, numbers 6 and 7. Again, pause the video or work ahead, one of the two. But number 6, first up, we got to decide which side do we want to work with. Okay, well, honestly, this is another one where, in my opinion, neither one looks simpler to me. They both look pretty messy. So you just kind of got to pick. I'm going to go ahead and like I've done with all of the proofs so far, I'm going to work with the left. If you couldn't tell, I do tend to work on the left side of my proof and make it match my right, unless the right looks more obviously messy. I don't know why. I think it's just that I like being able to have all of my work and then write equals whatever's on the right. There's just something about that for some reason I like how that looks in my work. Again, it doesn't actually matter though. Right, you can work with either side as long as you only work with one and get it to match the other. Okay, so I'm going to work with my left. So looking at that left, sine theta over 1 minus cosine theta, trying to get it to match my right. What could I do with my left? Okay, well, this is very similar to what we did in number 5, right? I could multiply by the conjugate of my denominator, which would be 1 plus cosine. I've got to do it to top and bottom. And I'll multiply that to the sine over 1 minus cosine. Our goal is to get this to match 1 plus cosine theta over sine theta. Okay? So multiplying by my conjugate, my numerator now is the sine times the 1 plus cosine. My denominator, foiling this out, 1 times 1 is 1. 1 times negative is negative cosine. Cosine times 1 is positive cosine, and positive cosine times negative cosine is negative cosine squared. Okay, this allows our cosines to cancel, so my numerator now stays sine theta and 1 plus cosine theta. Cosines have canceled. We have 1 minus cosine squared theta. And so now we're going to take a step back. We're going to look at our left and go, okay, what could I do to get my left to match my right? Okay, well, I kind of like that 1 plus cosine in my numerator. That's ultimately speaking where I'm wanting to end up, so I don't really want to touch that. That looks pretty good. What I'm wanting to adjust for the most part is my denominator, right? My denominator looks nothing like my other denominator. So what could I do to this 1 minus cosine squared? Okay, well, that's a Pythagorean identity. 1 minus cosine squared is sine squared. Now that we are there on our left, what could I do to change my left some more to get it to match my right? Well, I've got signs that can cancel here, which would leave me with 1 plus cosine in the numerator, a singular sign in the denominator, and what do you know? My left now matches my right, and my proof is done. Okay, one more for this objective, ladies and gentlemen. Number 7, we've got to decide which side are we going to work with, left or right. Okay, in my opinion, the left looks more complicated. It's got a fraction as opposed to the right, which just has all these little individual nice looking terms. So I'm going to work with the left again. Okay, so what could we do on our left? Okay, well, I don't really know what to do with my denominator there. I maybe might consider multiplying by the conjugate, but for now I'll leave the denominator alone because in the numerator we have a factoring possibility. What type of factoring is in that numerator there? Okay, well, that is cubic factoring. Cubic factoring, just as a reminder, is the one where when you have, let's actually call it a cubed and b cubed, you can soap it, right? This is a, same, a squared opposite, ab always positive. And so we can soap out that numerator because we have a tangent cubed x, so tangent x would be my a, and 1 is the same thing as 1 cubed. So 1 would be my b. Okay? So we've got our first term, same, second term, first term squared, opposite, first times second would be tangent x, always positive, second squared would be 1, and we have factored our numerator. And so then we take a step back, we look at the left, and we go, what could I do now to the left to get it to match my right? And we've got something that can very nicely cancel there, leaving me with tangent squared x plus 1 equals tangent squared x plus tangent x plus 1. And now that my left has come in line with my right, my proof is done. And that is objective 3.